Good morning. It is Thursday, April 23rd, and as I'm looking at this now, this sign that I have up there, which was a synopsis of the rules, I'm going to make reference to it, and then I'm going to bring it down and let you see it. Maybe you can pause the screen when I do that and copy it, but I am going to go back and point to it so you can see the importance of it when I go over the remaining six problems here. All right, so without further ado, let me get started on this. Starting with number six, what is the oxidation number of iodine in KiO4? Now, when you look up iodine on your reference tables, you're going to see the oxidation states listed are -1 is the first one. So if it's the BIC rule, the IDE rule, uh, it's going to be -1. That's its IDE. So iodide is -1. And then you're going to see charges of 1, 3, 5, and 7. Those are possible charges for it. If it's not in the binary ionic compound, then it could be one of those other rules. So in this case, it's not binary, it's ternary. There are three different elements in there. Three. There's K, I, and O, three elements, so it's ternary. Binary, it would be only K and I or some other metal and I to use that binary ionic compound rule. So I can't use that. I can't say I is -1. Probable charge for it in other types of compounds. Not this. We're going to figure out what it is. Okay? So I write down my formula. KiO4. And now, like I said, I'm going to go through my rules, okay? The most important ones are like up here after this word then, and I'll bring it to you so you can see it. Or maybe you guys can zoom a little bit and, see. I don't know what your devices are capable of. But it says elements will be zero. Well, there's no elements here, so none of these are going to be a zero. Ions will be their charge. Well, we actually do have a polyatomic ion here and a couple of ions, but we don't know what they are because they're not individual. Ions will be their charge if they're by themselves. Just one ion by itself, it's going to be that charge. That'll be the oxidation number. This is what we're going to use first. Compounds will sum to their charge. If there's a polyatomic ion in that, well, it's going to equal that charge as well. But this whole thing is going to have to equal zero. So we're going to sum this up to zero. And now we're going to use the rules for the elements as in compounds. I'm going to apply them in this hierarchical order. So it says in compounds, these are the always ones, group 1 and 2. They're going to be whatever charge they are. So group 1 will be 1, group 2 will be 2. And then fluorine is always -1. So what do I have here that fulfills that rule? Well, I have K. K is in group 1, that's +1. Then I go down, right? Now I have the ones that can vary. These are the weak rules. Then, if you take care of all this stuff up here, then we start looking for this. H. Do we have H? No, I can't assign H. Is there O? Yes, there is oxygen. Oxygen then will be -2. Okay? And I'm going to talk about cases when the hydrogen and oxygen are charges other than the ones that they have listed. I'll do some examples and continue on here. I think there's examples here. All right. And then now we're left with I. So in order for this to equal zero, one of these has to be dependent on the other. One of them has to be the weakest. I is the weakest. We could use the IDE rule, say it's -1, but if it's -1, it's not going to be zero. So now we're going to have to figure out what I must be. All right. Think about it for a second and remember how many you have. This -2 is for each oxygen. There are 4 oxygens. So really that's -8. Those oxygens are -8. K is 1. So how much more must I be in order to make a 0? I has to be what? That's right, +7 you say. Good job. So yes, I is +7. +1 +7 -2 equals 0 if you take into consideration the fact that you have 4 of these -2's. So that's how it winds up being equal to 0. Okay? So your answer is choice 3, +7. Uh, question number 7. What is the oxidation number of manganese, Mn? It's not magnesium. Oh, they actually give it to you. Oh, it's like the same exact problem. It's the same exact problem. There's no difference between Mn and I because the K and the O are still the stronger rules. So I'll just write it up again, do this one a little bit more quickly. K, M, N, O, 4. Since it's a compound, it's going to equal 0. K gets its rule first, oxygen next. -8 for all of these, plus 1. I'm going to do something with this problem that I'm going to ask you to avoid doing. Don't do it. Do it in your head. Do it on scrap paper. Don't write it into the problems. You might say, well, what's the problem with writing it underneath? When we go on to the next phase of this, when we track the changes in oxidation number, then you're going to see, oh, if I write that there, it's going to make a mess of my problem. I'm not going to be able to answer it. All right? So these are really -8. This is +1. It's got to equal 0. That means Mn is +7. So I'm going to put my +7 up here. Now this stuff on the bottom, okay, I'm going to get it out of here. We do not want to leave it there. Okay, want to get rid of it. Those are the numbers that we need: the +1, the +7, and the -2. Right? So 6 was 3, 7 was 4. Both answers were the same, +2. Moving on to the 8. To 8, oxygen has an oxidation number of -2, and which are the compounds? Great, great, great question. This is how we learn how oxygen can even be positive. And again, it all depends on these rules, which I promise you at the end of this, I'm going to break it down and put it in front of you closer. I'm just going to talk it out, and then maybe you should write this stuff down as you do some more of the problems, or if I put up a worksheet or something on this, you'll be able to use that to refer to it. All right. Oxidation, or at some point, I'm going to give you a test on this. Look, if I give you this sheet, if you're taking it at home, uh, I I guess it's wrong to say, but I have no way of stopping you from using it. You know what I mean? So, you know, use it as an asset. I have the feeling we're going to be doing this, right through the end of June. I don't know how long they're going to make us go, but just from what the governor was saying yesterday, it makes me less and less confident that we'll be back face to face, which you know it's not good. I would have said a bad word, but I try not to say bad words. All right, here we go. Anyhow, so the first one, O2, right? That's an element. It's going to be 0. So choice 1 is 0. Don't even need to say I would do anything with that. The second one, NO2. NO2 is actually going to be the answer here. All right, so we write down NO2. Okay, you go through your rules, right? This is going to add to 0. It's not an ion. There's no polyatomic ion. In compounds, group 1, group 2, and fluorine. Is group 1, group 2 of fluorine here? No. Is hydrogen here? No. Is oxygen here? Yes. All right, oxygen's the first rule we come to. That's -2. It has to add to 0. Something's going to have to adapt itself in order to allow oxygen with the stronger rule be its -2. Here, the nitrogen's +4, oxygen's -2. That's how we get our 0. That's the answer. Okay. Now I'm going to look at why the other ones aren't -2. Okay. So I'm going to erase and move along. All right. Choice 3 is Na2O2. Watch this. Na2O2. All right. The rule for oxygen is down here. Na is in group 1. That rule is up here. We apply that first. So group 1 is +1. Right? Up here, it's compound. Right? I gotta fix this. I just realized this got sum to 0. That says 0. That mess. Compounds will sum to 0. You know what? I'm not gonna bring that down to the camera now. I'm going to rewrite it more neatly. I'll either take a snap of it, type it out, and send it to you as a link. I'll do something because this is going to be helpful to you. It's just too much of a mess to like make you take a close up of that and say, "Oh, copy this down." I'll do it neat or I'll type it out. Maybe even tomorrow morning I'll get it sent to you or something. But I will, promise. Anyhow, so 3 times I think I've read it and used it for problems. And but anyhow, compounds sum to 0. Okay, so this has to add to 0. Okay, now since the rule for Na group 1 is higher than the rule for oxygen, guess which one's going to change? It's the oxygen that's going to change. Oxygen is going to become a different value than -2. Oxygen is going to be -1, which if you remember yesterday or the day before, we said when it's -1, it's a peroxide, okay? So this is actually sodium peroxide because oxygen is a -1. Because we have 2 NAs at +1, 2 O's at -1, making a +2 for both and a -2 for both, equaling it to 0. If we used the common rule for oxygen and that it's -2, right? 2 times -2 would be -4, and then the 2 positive ones for sodium, this would not equal 0. All right? Oxygen must be -1 here. Okay? And the last one, choice 4, if you didn't already figure it out, we got OF2. All right? Ask yourself a question. All right? What has the stronger rule, oxygen or fluorine? Well, if you look at my list, which I'll send you later, you'll just have to trust me. My list says fluorine is always -1. So fluorine's not going to change. So fluorine is -1, okay? I'm going to write that down here. The oxygen rule, compounds will sum to 0. So if you have 2 fluorines that have to be -1, that's -2. What's oxygen? Wow. Oxygen can be a +2 even. I mean, it's rare. The only time oxygen will be positive is when it's with fluorine. Fluorine is the greatest electronegativity. Oxygen is second. So the only thing that can change oxygen is fluorine. Oxygen and fluorine can change everything else, but oxygen can't change fluorine. It's a hierarchy, which hierarchy based on electronegativity. The higher electronegativity will get its negative charge and its octet. It reverts all the way back to that stuff that we learned like end of September, early October during atomic structure. All right, so number 8, great question. The answer to number 8, by the way, I'll reiterate, was choice 2. Number 3, I just explained it. All right, number 9, oxygen will have a positive oxidation number when with fluorine because oxygen has a stronger rule. All those other ones listed here would fall under this, the binary ionic compound rule, which is the RDE rule, which is group 17 are all -1s if you look at your periodic table. Group 17 is -1, 16s are -2, 15s would be -3. In theory, 14s could be -4, but there's really only one element in that group that would go negative based on its electronegativity. That's kind of carbon. Silicon, it's transition metal, so it really doesn't form that many ionic compounds. So it really would probably not be negative, but that's not a common enough problem for you to worry about. And number 10, which compound has hydrogen, right? It's asking about hydrogen, a -1 oxidation number. I'm going to write all 4 of these down and go through them with you. So I think we did all the examples. We do, in fact, need to do more. On the next page, we start doing equations. I don't know if I want to assign those to you yet or do a couple of practice problems with you first. I just need you to make sure you know how to do all your oxidation numbers. Yeah, before you can do anything else in redox, you have to learn how to do the oxidation numbers. So this first week or so of lessons is probably the most important. What I might do tomorrow, I'm actually thinking about, instead of having you work out of the book again, I might, like I said, I want to type that up and post it. Also, I think maybe I want to give you like 10 problems for you to try on your own. You try them on your own, and then I'll explain the answers to them. And then hopefully, when you're experts in the assignment of oxidation numbers, uh, then we can start breaking down those oxidation numbers and how they're applied to equations. All right, so let me do this last one. It's NH3KH, NH3KH, uh, HCl and H2O, HCl and H2O. We're going to look at the first one. This is an unusual case. In almost every compound that I teach to you, the second one is the negative. There are a series of compounds called organic compounds, which we're probably not going to start. It'll be our last topic of the year. We're probably not going to start it for about 3 weeks or so. We're going to probably work on this, another 2 to 3 weeks with testing and everything. And then we'll go into organic. In organic chemistry, the second one is positive in the hydrocarbon compounds. You'll see that as an example. And then in NH3 and NH4 positive, the ammonium ion, and I've discussed with you and discussed this with you in class when we were doing it, that there are a couple of exceptions. This is one of them. And it comes to you that you're able to figure that out. It comes to you, again, by these rules that I have here. And I promise you I will type them out and bring them, send them to you as a link or something, and then you can click on it. And I strongly recommend you print it out, but you can if you want.